Good morning, good evening, good afternoon. This is the group number three, and the title of our presentation is The Use of Enzymes on Diagnosing Liver and Heart Injuries. First of all, I want to thank all of our colleagues for watching this presentation, which, by the way, is being performed in English, not because we want to be better than other people, but to indeed take our medical program to another level in the scientific scenario. We salute our professor, Dr. Igor Nase, for giving us the honor of presenting on such an important subject, and we hope our explanation is clear enough so everybody can understand our work. So, the first question is, what are enzymes? So, enzymes are biocatalyzers that speed up chemical reactions in our organism. They can be either proteins or RNA itself. For example, sRNA catalyzes alternative splicing. They are located in specific locations in the human body according to the process done by that specific organ involved, meaning that we will not find certain enzymes in certain organs. That also means that by measuring the concentration of a specific enzyme in the blood, we can correlate that enzyme to a tissue and know that there's something wrong going on. Enzymes play a major role in the diagnostic analysis of hepatic and cardiac injuries, providing vital information about these organs' integrities and well functioning. Comprehending the importance of these specific enzymatic markers is fundamental for the precise diagnosis to be given and also for the adequate monitoring and developing of treatment strategies assisting patients with hepatic or cardiac lesions. So, through the analysis of these enzymes, we can see if there's any injuries going on in the liver and in or in somebody's heart. That's what we're going to talk about in this presentation, and that's what's about. So, to begin, we're going to talk about the human liver and liver diseases. So, the liver is the biggest glandule in the human body and the second biggest organ in the human body. It is responsible for many metabolic processes. As we saw in the biochemistry classes over the semester, there are many metabolic processes going on in the liver. Um, it also filtrates and stores blood through the portal venous system. And liver diseases are very common because this organ is responsible for so many things. So the liver gets easily overloaded with work. And what are the enzymes that we can look at and tell that a person has a liver injury? So there are three main enzymes that we can analyze and see if a person has a an injury going on in that person's liver, of course. The first one is ALT. ALT is short for alanine aminotransferase, and the ALT enzyme catalyzes the transfer of amino groups from the L-alanine to alpha ketoglutarate, and the conversion products are L-glutamate and pyruvate. The process is critical in the liver in the tricarboxylic acid (TCA) cycle. We can tell by the increasing concentration of this enzyme in someone's bloodstream that there's possibly a hepatic injury because ALT is mainly present in the cytoplasm of hepatocytes. So ALT is in the liver cells, more specifically in the cytoplasm. And when there's an injury, this enzyme gets thrown into the bloodstream and its concentration in the blood increases. So if we order actually, because we're doctors, of course, if we order a blood test from our patient and ALT is high, the concentration of ALT is very high, we can say that that person has a liver injury because of that concentration. The second enzyme is ASG, and ASG is short for aspartate aminotransferase. ASG is not only present in the liver, but it's also present in the heart, in the muscles, kidneys, and etc. That's why even if we do get a high SAG concentration in the patient's blood, we'll still have to run an ALT test to confirm if the injury is actually in the liver or somewhere else. The most common causes of the increase of the aminotransferases, both ALT and ASG, are hepatitis, drugs, including tea, supplements, and steroids, and alcohol abuse. It also could be Wilson's disease or hemochromatosis, but those diagnoses aren't very common in hospitals. The third one is ALP, and ALP is short for alkaline phosphatase. It's present in many tissues, but mainly hepatocytes and osteocytes. That's interesting. It can point to a biliary obstruction. The differentiation between these two conditions, uh, a liver injury or a bone injury, because ALP is present in hepatocytes and osteocytes, this differentiation, can be done through a test called BULP. But we're not gonna go deep into how BULP works. But you have to make the differentiation between these two in order to know if it is a liver condition or not. So we talked about liver. Now we're going to talk about heart. We can tell by the concentration of certain enzymes in the human body that a person has or not a heart injury going on. What is the human heart? It is a crucial organ in the human body, responsible for keeping the right internal pressure of the system, the cardiovascular system, continuously leading and transmitting blood volume to all parts of the body, making the nutrient and gas exchange between cells and blood vessels, and collecting the blood from tissues back to the heart. We all know how it works. According to the World Health Organization, cardiovascular diseases are responsible for 45% of all deaths, reaching the number of 30% of all deaths in Brazil. But what enzymes are used to detect heart injuries? So the first one is troponin. Troponin is a gold standard enzyme on the diagnosis of acute heart failure or myocardial ischemia. It is a controlling protein present in the cardiac myocytes. The increase of the concentration of troponin is a very specific biomarker of cardiac lesions because it literally exposes the death of heart tissue. The concentration peaks in 24 hours and fades away in a week to 2 weeks prompt. The second one is CK, and CK is short for creatine uh, kinase. It is an enzyme involved in the process of forming creatine phosphate, which assists our muscles with a rapid recycling of energy by adding a phosphate group to the ADP present in the cell, making it a new ATP molecule available. It usually indicates heart complications such as acute heart failure. But if that happens, the CK will only peak about 24 hours after the episode, after the acute heart failure. And it will fade away in 2 to 3 days, allowing the monitoring of the patient's situation. High levels of CK can also point to muscle fatigue. The third enzyme involved in this process of seeing if the patient has a heart injury going on is galactin 3. So, galactin 3 is a profibrotic protein present in many cellular types like macrophages. It leads heart cells, lung cells, kidney cells, and hepatocytes to fibrosis. It is usually related to heart failure if there is high concentration in the patient's blood test. So all of those three are related to heart failure. And if you run a test in your patient and you see a high concentration of mainly troponin, though, mainly troponin, if you see that there's a high concentration, you can tell that your patient probably is having a heart injury, has a heart injury. And troponin points to the death of heart tissue. So there was an acute heart failure. With all that being said, we can conclude that liver injuries, heart injuries, can be discovered through the analysis of the concentration of enzymes in someone's heart, in somebody's, not heart, somebody's blood. Um, and that helps the doctor to know what's going on. It provides a faster diagnosis. And when we have a faster diagnosis, we can have a more efficient treatment because we actually know what is going on with our patient. So, this is a very important process of knowing what those enzymes do, where they're located, and then testing for the concentration of those enzymes and seeing that the concentration is high, and it shouldn't be high by now because there's not a natural condition for them to be high in someone's blood. So we We see it and we treat the patient according to the to what's closest of what he has. So if I find, for example, a very high concentration of troponin in my patient's blood, all indicates that he has an acute heart failure. So what do? I gotta treat him for that. I gotta give him the medicines. I gotta give him everything and try to treat him as fast as I possibly can. So that's how important the whole process is, and having that in medicine, and nowadays medicine, more modern medicine, to be more formal talking, is very important because we can diagnose really fast, and we can know better the human heart. So that is basically it. I hope y'all understood me. I hope it was clear enough. It's not very complicated to understand all of those things. There's more to be said. I'm not an expert though. I could not I cannot have a lecture, a 5 hour lecture on this, but I hope y'all could understand me. Once again, we're group number 3. We hope this was good, and we want to thank everybody for watching us. We want to thank people for helping us with the research, because you got to research a lot to do a presentation like this, a seminary like this one. And we want to thank our professor again, Dr. Eagle Nasset. Want to thank you for the opportunity of doing this. And we want to thank God also for this, his beautiful creation. And it's been a pleasure um, studying all of this. I hope y'all have a good day, and thank you. Thank you for watching me. That's it.